I'm going to just wait 30 seconds for Anna, who got kicked out for some reason. You are going to want some sort of straight edge because we're going to have to draw some diagrams, and we're going to have to talk about a couple definitions here. Okay, you may want to make a note of this if you haven't looked at it maybe in your textbook already. But what's going on here is when we're talking about our word problems, we're going to see some descriptions like angle of depression, which is not how sad you are. Okay, it's not a comment on mental health. There's usually a couple comments about that when we're in class. So angle of depression and angle of elevation. And usually it's talking about someone's sight lines. So quite often we'll see a problem like, all right, there's a plane flying over Toronto. The pilot in the plane looks down and sees the airport at an angle of depression of, okay, in this first question, it's 22 degrees. To understand what the angle of depression is, we need to draw on, that didn't show up very well, the horizontal, which is an imaginary line that's parallel with the ground. Now the angle from the horizontal to the sight line, that is the angle of depression. Okay, so the angle down. The other way that we may see for angle of elevation is if someone on the airport looked up and saw the plane, the angle from, again, the horizontal up to the sight line is the angle of elevation. Yeah, those are the only two definitions we're going to use for our word problems. So jot those notes down so that you can recognize them. And we're going to start. What's different today about the word problems that we're going to do versus the word problems I gave you in the worksheet on Tuesday is I'm no longer providing you with a diagram. So you are going to have to draw some diagrams on your own. Let's get started. Suppose a plane is coming down for landing. Oh, sounds familiar. At Toronto's Pearson International Airport. The angle of depression of approach is 22 degrees. The plane is 3,500 meters from the landing point along the ground. How high is the plane to the nearest meter? Let's start by drawing. We know it's going to be a right angle triangle. So I'm going to draw my right angle. That's important. Here's my plane. I'm going to call it P. A for the airport. I don't know. G for ground. Hi, Anna. Welcome back. I don't know what happened there. I'm sorry about that. Okay, so here is my diagram. Now, what information can I put on here? I know that the plane is 3,500 meters from the landing point along the ground. So this distance right here is 3,500 meters. I know that the angle of depression of the approach. So I'm going to sketch on my invisible horizontal. And this is 22 degrees right there. We're being asked to find the height of the plane to the nearest meter. We currently don't have enough information inside the triangle. We need one of these angles. There are two options here. Someone give me a way to find one of those interior angles. Might need to think back to some grade 9 angle stuff. A is 22 degrees. How did you get that, Grace? You're correct. We got that because of the parallel line theorem Z. So remember, when we have two parallel lines that are intersected by a diagonal, the interior angles of the Z are equal. And I need to say that here. I need to explain how I know that A is 22 degrees. The other option is I know that angle P is 68 degrees, right? Because of the complementary angle theorem. And that's that these two angles will add up to 90 degrees. Now I have the information I need. I can use, well, I'm going to use tangent because I want A. So I can do opposite over hypotenuse from angle A, or I can do, sorry, not hypotenuse, opposite over adjacent, or I can do opposite over adjacent from angle P. Both give us the same answer. I'm using A because that's the first angle we found. So I'll say tan theta equals opposite over adjacent, which gives me tan 22 equals A over 3,500. Rearrange to isolate A. And we're going to the nearest meter, so that gives me 1414 meters. Therefore, the plane's height is 1,414 meters. So that's 68. And that's it. That's it for our word problem. So if you can draw your diagrams today and remember some of these angle theorems, you're going to be in a pretty good spot. Why don't you move on to the next question, number 2, and draw the diagram. See what you get, label all the information you know. I'm going to give you 60 seconds. All right, here's my diagram. Yours may be reversed, but do you have the same labels? 8 meters on the hypotenuse, 7 meters on the height, and we're finding the angle that the ladder makes with the wall. So that's up here. So what trigonometric ratio would we use to solve for that angle? Yeah, cosine, because we have adjacent and hypotenuse. Go ahead and solve, please. So I took my ratio, cosine theta equals adjacent over hypotenuse. I know adjacent and hypotenuse, so I filled them in. I need to isolate theta, and since I can't divide by a mathematical function, I can use the inverse. So then I have theta equals the inverse cosine of 7 over 8, round to the nearest degree, and I get 29 degrees. Feeling good? Feeling great? Number 3 is another plane question. Go ahead and start the diagram. Okay, I'm going to draw the diagram. Hopefully yours is done. Here's my plane. Doesn't matter whether you have it going to the left or to the right, east or west. But I know that its altitude makes a 90-degree angle with the ground. It's at a height of 2,500 meters. And the angle of depression of the airport is 32 degrees. So angle of depression means I'm going to draw on my horizontal. And that's 32 degrees there. We're being asked, how far is the plane from along the ground? That's my unknown. So give me either angle A or angle C and tell me the angle theorem that you use to solve it, please. Okay, angle A, yes, is 58 degrees, Grace, but it's not because of PLTZ, it's because of the complementary angle theorem. Remember, they add up to 90. Angle C, Victoria Good, is 32 degrees because of PLTZ. So you can use either one of those angles to solve for A. Go ahead, choose your favorite ratio. Not favorite, one of them won't work. Two of them won't work. It has to be tangent. Because we don't want anything to do with the hypotenuse right now. Okay, I'm going to work with angle C this time. So tangent of 32 is 2,500 over A. This takes a little bit more to rearrange. Multiply both sides by A. And divide both sides by tangent 32. And we are going, okay, doesn't specify how much to round, so our default is to 1 decimal place. So we have 4,000.8 meters. And if you use the other angle, If you used A, you should get the same answer. If you use the other angle, yes, but you'll end up with the same final answer. So I worked with the 32-degree angle, so tangent is opposite over adjacent, 2500 over A. If you worked with angle A, you'd have tan 58 equals A over 2500. And when you rearrange, though, you get the exact same answer. This is the beauty of trigonometry. Delicious. Let's keep going. Yeah? 3 questions to go. And then you're done learning for the year, which I know makes you guys very happy. Okay. A video camera is mounted on top of a 120-meter tall building. When the camera tilts down 36 degrees with the horizontal, it views the bottom of another taller building. How far apart are these 2 buildings? I'm going to start by drawing these 2 buildings. That one's taller. Here's C for our camera. Now, when the camera tilts down, it can see the base of the other building. And we're told it tilts down 36 degrees with the horizontal. So that's 36 degrees right there. This building is 120 meters. Go ahead and solve it. Remember, first, identify your unknown angles and how you got them. So you can use PLTZ, which gives you angle A. Boom, boom, boom. Or angle C is going to be 54 degrees because of the complementary angle theorem. And from there, you're going to use tangent because, again, we're not worried about the hypotenuse. Now, if I were looking ahead and trying to save myself some work, because work's smart, not hard, right? I'm going to use angle C because that's going to give me opposite over adjacent, which means my unknown is on the numerator, which makes it easier to rearrange. It's just one simple multiplication. Doesn't mean the other way is wrong. Doesn't mean it's that much harder. I'm going to save myself a step. So I have tan 54 equals C over 120. And again, we're going to go to 1 decimal place for a distance. And I find that they are 161.2 meters apart. Hold on. $165.2. Any questions about this one? I'll give you 2 minutes to catch up on these 2. If you need anything still, I'll zoom out a bit. And then we're going to move on to our back page. If you're feeling great about these questions, go on to the back page and try them on your own. Okay? We'll catch up in 2 minutes. Okay. Let's wrap this up. A communication antenna with a height of 12.5 meters is attached to the roof of a school and held in place with two 16-meter guy wires. So here's our roof, and here's our antenna that forms a 90-degree angle with it. A guy wire is a wire that's securing the top of a structure to the ground. So these wires are both 16 meters, and the height of the antenna is 12.5 meters. So we're being asked, what angle do the wires make with the roof? And what distance from the base should they be secured? These are identical triangles. I'm just going to solve one of them. And that gives us the answer for both. So over here, I have opposite and hypotenuse, which means I'll be using sine, so, of SOHCAHTOA. So I get 51 degrees for that angle. Once you got that, we could have all three angles. We need to go this side. Just working with angle C, I could use tangent for opposite over adjacent, or I could use cosine for adjacent over hypotenuse. We haven't done a lot of cosine today, so I'm going to use that. Cosine theta is adjacent over hypotenuse. And there's my distance. So therefore, the wires will make an angle of 51 degrees with the roof, and they should be secured 10.1 meters from the antenna. That's singular antenna. Time to do our very last word problem of the year. Go ahead and start looking at your diagram, seeing the questions. I'm going to move on in 1 minute. All right. An electric cable needs to be laid both underwater and on land from a power station on an island to a tower on the shoreline of another island. A surveyor made measurements as shown in this diagram. So here's our station on one island. Here's the tower on the shore of the other. So we see there's 85 meters of land. We don't know the distance underwater, but the surveyor measured 250 meters out and an angle of 43 degrees. So our first question is, what length of the cable is underwater to the nearest meter? I'm going to label my sides here for easier reference. We need to find B. So go ahead and find B, please. For question A. We want the hypotenuse, so that means we're going to use sine or cosine. And in terms of what we have our adjacent side. We have an angle, adjacent, and want hypotenuse. So that takes us to cosine. And we're left with this expression to rearrange. So I'll multiply both sides by B. That gives me B times cosine 43 equals 250. Divide both sides by cosine 43. And that gives me, I'm going to the nearest meter, so 342 meters is underwater. What's the total length of the cable? Well, we've got 342 meters underwater and 85 meters above. So that is 427 meters. Now, it's more expensive to lay the cable under the water. The cost of cable underwater is $500 per meter. The cost of the cable on dry land is $450 per meter. What's the total cost of the cable? Well, we have 342 meters underwater, and that's $500 per meter. We have 85 meters above water at $450 per meter. That gives us 171,000 plus 38,250 for a grand total of $209,250. And that wraps up our word problems for trigonometry. Before you go, so there are some word problem practice questions from the textbook I listed. As of Saturday, I'm going to post the remaining stuff for the course, which will be one assignment, one practice quiz, and one quiz. And it's only based on the stuff we did this week. I just want to thank all of you guys who are showing up live for these lessons. I know not everyone is able to, so if you're listening to the recording later, I don't blame anyone, but I really look forward to these live lessons with you guys because it's the tiniest bit normal and get a little bit of interaction, like I can pretend that we're back at school. So thank you for trying to be here whenever you can. I really look forward to seeing all of you guys in September, whatever school ends up looking like. I know we'll be in some capacity, and I hope that you have a wonderful summer. I'll still be running the drop-in sessions up until the 22nd of June, so feel free to pop in. Otherwise, make sure you reach out if you have any questions. Thanks a lot, guys, and have a wonderful day.